Okay, welcome. I've been a little bit under the weather, so yeah, I missed a couple of days here, but I did a little bit of stream. So I've started to use a little library, very small library for just convenience functions that do stuff with IO stuff. So write file, read file, printing to to the standard out, which is kind of trivial now with the write file here. However, yeah, I did this get line as well. I'm not really using this, but it's like you can read stuff from the standard in. Read file by file name, and yeah, it's a little bit easier. Also, especially in my project where I'm using JSON a lot, so I have write JSON file. However, write JSON file is pretty simple. If you have a write file function with this formatting style, it's pretty easy to format JSON because you just use the standard JSON formatter, and that will do it for you. So that's very nice. Then we have read JSON file, which is a little bit more involved here, but it basically you can pass in any type that you want to read in as a JSON, and an allocator, file name, and then options. You can optionally pass in a directory if you don't want to use the current working directory, because that's the default. And then you can also pass any parse options to the JSON parser, such as ignore unknown fields, which I'm using a lot. Okay, so that's just I started to write this because I realized that okay, it's kind of annoying to have to do these things like catching these errors and logging stuff out. So I just made this like generic way of doing it. Also a nice like error message when something is wrong with the JSON file. And so yeah, that's how this looks. The only thing that could be a problem here is this part here, which is like I've ran into problems using this function, parse from token source leaky, because sometimes it feels like it's allocating stuff and there's no way of deallocating it. Like I don't know, it's yeah. So what I've done is when I use this, I'm using it, here for example with, editor session. So I have a file where I save in the editor, where I save the editor session in a JSON file. And it's basically storing stuff like what documents you have opened, what project you have opened, stuff like that. So it's restoring that session when you reload the editor. And we use this read JSON file to read it in. And the thing is that this editor session has a bunch of strings and stuff that needs allocation. So when we read it in with read JSON file, we're gonna get a bunch of stuff like allocated in this thing. And I don't really have, I'm trying to shy away from writing manual allocators for these things in favor of using like arenas to allocate everything on an object or on a struct, and then just releasing everything at once with the arena allocator. So what I'm doing here is I'm creating an arena allocator first, and since we're at this stage, in this context, we don't want to have this around, so I'm just deinitializing at the end here. And then you can get the allocator from the arena and then use that in the read JSON file to read this with this arena. And so we can make sure that everything that this read JSON file function is allocating here is gonna be released at the end here. Even though it's not really a big deal, since this is just a one one-time call, but it's the principle here where I'm trying to have no leaks, and yeah, and in other situations where it actually matters, where you don't want leaks, where it matters more, then it's a nice way of doing things. And sometimes you might even want to store like an arena in the struct itself. However, then it becomes harder to read with read JSON file. But yeah, and that's why the JSON library in the standard JSON library has a built-in function for returning basically a struct with the arena built in. So you get the value in one field, and then you get an arena in another field, so that you can easily deinitialize the whole thing. But yeah, and I should probably make maybe a version of that, so you don't have to do this yourself, because this is basically, actually let's do that right now, because I feel like that should be like a pattern that is probably gonna be good to have. So basically, it's gonna do the same thing as all of this, except we're not calling source leaky. We're gonna call parse from token source. Yeah, it's just called parse from token source. So, let's see. Now, I guess there is a way to sort of encapsulate all of this. However, then we would need like another like struct. I guess we could do that as an exercise here as well, like read JSON context. Excuse me, still a little bit under the weather here. Read JSON context, right? So what do we need? We need a buffer. Just define this like this, undefined. There we go. And we need the I guess we can just copy options. Well, let's see what we actually need. So we need to pass in options. So basically we need to, what we need is, we need to call this function down here. This is the only thing that is like different. So let's see. So what do we need here? We need allocator, JSON reader, parse options, and the file name probably, yeah, and the type. Okay. Let's put this on here for now. Read, I guess. Okay. I'm gonna say like read leaky, and well, we could pass in like allocate, like everything we need actually, I guess. Whoops, this is the wrong struct over here. So I guess we could pass in like comp time t, allocator, the JSON reader. Well, you know what? We do want to sort of do all this as well, so I'm gonna copy all. Well, I'm gonna move this over here, so we'll have like an init. I'm not sure what to call this. I guess prepare or something. I don't know. And then self is the context. And there could be an error in here, so let's have this error type. Okay. So we don't need this buffer since we already have a buffer on self. Right, that's the whole point here, to keep this sort of a shareable or yeah, this logic to be sort of shareable. This state here is supposed to be shared between these functions, so that's why I'm doing it like this. And so let's see, so we got all this. Now the only thing we need here is the JSON reader, I think. So the JSON reader, and also we can't defer file close, or we can't defer this, so we have to store these things as well. So we have to store the file and the JSON reader. Luckily they have pretty simple types here. Now this is also like referring to this reader, so we need this reader as well. Let's say file reader, I guess, or no, that will be too much like the actual file reader. Like there's a standard fs file.reader. This is a standard IO reader. But this could be a, no, hang on, this is the file reader. This is the file reader. Yeah, this is the file reader. So file.reader, that's what it is. So we'll say that this is self.fileReader is equal to that, and then self.JSONReader, come on, is that okay? And then this would be self.fileReader. There we go. The allocator we can actually just pass in, that's fine. We don't need to copy that. Oops. Okay. So, and then we don't defer this. What we do is we say we have the initialize function. And we probably need this to be that. Alright, so file close. I think we want to initialize the reader first. I'm not sure if it doesn't really matter, I don't think. Yeah, but we do want to do that. I wonder what this actually does. Like, maybe it releases some stuff with this allocator. Okay. So now we don't defer these things. Right. So, do we need to store the file actually? Yeah, we need to store this file because... So the file doesn't really need to be like... The file can be copied, so in that case we don't need this to be a pointer. However, I think the JSON reader, we need it to maybe be... I'm not sure actually. Let me look this up, because that changes the function signature. So where's my browser? Here. There we go. Okay, so standard, what was it? JSON reader, deinitialize. Alright, so this needs to be mutable, so which we can see by the pointer type here. So this, so we need this to be mutable here. Okay. Right. So let's see. Self.file. So this needs to be self.file as well. Is there anything else that I forgot here? I don't think so. The only thing is the error message here, because the file name, like the file name is relative to this, to the directory that you're opening with. So you don't, so this file name could be, you know, it could be not relative to, like, it doesn't make sense if you open the program in one directory and then you get this file name which is not in the directory. So I think what you could do is there's like a dir alloc path or something, or let's see, here, like real path. but it could be that the path doesn't exist. So if the path doesn't exist, then this can't return. Like, it has to exist for this to actually return something, as I found out, which I find is like, I want a version of this that actually returns something even if it doesn't exist. Because I wanna say, okay, this file did not work out because it doesn't exist. So and I mean, what you could do as well is you could say, let's say directory, and then there is, where is the thing, functions, values, handle. Wasn't there a like path to this directory or something? Like, what does this actually do? Like, if you look at the source code here. Excuse me. So W, Windows, open file, subpath W. Okay. Well, let's just look at that, I guess. Windows. So a subpath, we should have like the directory. I'm just checking how they actually, I guess they have to call like a syscall to get the directory path or something. Root directory path is absolute. Wait, but where is the? Yeah, this is the. Oh. So. Wait. No. Oh, it's a file descriptor. Okay. So, okay. Excuse me. Okay, so okay. But is there, but maybe, okay, maybe there's a way to get the directory somehow. Because this real path would be perfect. The canonical is absolute path name. Path name relative to this there. Path name absolute, it ignores. Yes. This function is not universally supported. Currently hosts. Okay. It doesn't say that the path has to exist, otherwise there's an error. So I feel like that is weird. But maybe you can do this. No. Where did you get the actual information? Stat file. Stat. Returns method for file side directory. No. I don't know. It's weird that you can't get out the path. I mean, I guess you could say real path and then just a dot to get the actual path name. I guess that is the thing. And maybe that's why it's only supported here, because yeah, that's where it's, I guess, currently implemented. But yeah, so you could, so what you could do is say real path dot, okay, I'm making a buffer here. Let's just make, well, there is like path max u8, which is actually, this is how they do it when using certain functions, as I've seen. So that should be fine. And I believe the second first path name and then out buffer. Okay. Can there be an error? Yes. So let's just catch, or I mean, we're in a catch already. Okay. If we want to be thorough here, and we return this error. Well, I want to return, I want to return this error. This is a separate error that is, we just want to display. Okay. So it's basically, if you can't open a file, we get an error. We want to display the relative path to the current working directory. Wait, what the hell am I doing? Oh yeah, because this will be an absolute path. Absolute to dir here. Okay. And then to get the relative, we call relative, and I believe I need an allocator here. Oops. Yes. Allocator. And then from to. So from is, I think, this. So we need the absolute file name. It's gonna, and I will put this. I will put this in like a function that takes a I will put this in a separate function, so we don't have to do this all the time, because we have a couple of places where we need to do this. But the absolute file name is then going to be join, or path join absolute dir path to, well, you need to do this. And then we'll join it to the file name, because file name is relative to the directory. Okay, so then now we have the absolute file name, and here I'm just gonna do this is like an out of memory error. I guess we'll catch this as well. Alright. And if we have that, then we can do relative from this, I think, to, oh, okay, and now we need another one. absolute buffer, and no, this is the dir buffer, and we need a CVD buffer. Now let's get this out of the way here. So that's the dir path, absolute current working directory path. Sure, we'll have the same error message, whatever. Now it feels like I'm jumping through a lot of hoops here to get this working, but yeah, I'm not sure. Also, this could blow up the stack. I mean, the path max on Windows is huge, I think, and on Linux it's not as large. So I think it's like 4 kilobytes. Let's see. File system, no, POSIX, path max, system. So on Linux, path max is, yes, is 4 kilobytes, and plan 9. Interesting. It's 1023 on plan 9. Interesting. Hello, Two Step. How's it going? Welcome back. Oh, Windows 260. What? That can't be real. I thought I read somewhere where the path max was like, oh, path max wide. Okay, maybe they changed that. I don't know. Anyway, just buffering. Oh shit. Okay, let me double check. Hello, hello. Well, that's unfortunate. All right. Sorry. Okay, let's just continue. I don't think there's anything wrong with the stream. I think it might be maybe your Two Steps internet there or something. I don't know. Anyway, relative. So here we're gonna do 1080 is the only option. Might try lower bitrate in the future if it's not too much trouble. Alright, let's see. That's strange because, well, there has been complaints, but that's what's when I had like dropping frames and stuff. Right now, I don't. There's no dropped frames. I don't know. But Twitch does complain that I have too high of a bitrate, so that might be what the problem is. I don't know. Okay. Let's see. Relative. Yeah, from file name to, and now this would be the current working directory path. Oops. Like this. Right, so now we should have the relative file name, so now we can use that. So now it makes more sense because we're showing the file name as being relative to whatever, you know, the current working directory is. And so we will take this and move it into a function and call this relative to current working directory. And we'll put in a directory here, and what else do we want? Oh yeah, and this should be and the file name. There we go. And this is a thing there, and then we get this out that we need to actually allocate as well. So we'll do this. There we go. And now we can return this as being relative. There we go. Alright, so let's get back somewhere. Wait, where? I mean, this. So if there's an error with this, I guess we'll return it. I guess we'll just have to return the thing. And the directory is options.dir. Wait. Okay, let's back up a little bit. I'm not sure what I did here. Let's back up. Did I remove like the wrong thing? Oh, this is in the okay. Sorry, yeah. no, that's fine. There we go. Okay, so oh yeah. So I was in the middle of moving things out of this function over here. That's right. So here we get the relative. Seems a little bit better in the Zen browser, but still mostly buffering, so I don't know. Doubt it's your fault. Every other time I've caught you, there were no issues. Anyway, carry on. Hoping. Okay. Well, that's not great. Maybe I should fix it right away, actually, but I'm not actually sure how to do that, so I have to do some research because yeah, because of the setup I have. It's that's too bad. I mean, I could lower the bit rate, I guess. But it is kind of weird because when I go to the stream, I see it perfectly, I think. Yeah. So for me, there are no issues, and I haven't gotten complaints about the current sort of setup right now. But if I look at the bit rate, it's like in the red. Let's look at how do you do it? Like, what is a good bit rate for Twitch? 6,000? Up to 6,000. An average bitrate of up to 6,000. Okay. But the hard limit for most streams is around 8,000. Okay. The best bitrate depends on internet connection upload speed, hardware desired video quality. You can use tools like OBS, auto configuration to find optimal settings. Recommended 6,000. Okay. So maybe I'll lower it to 6,000. Maybe that, yeah, we'll try it and see. Maybe. OBS, I do have the power to do it, I think. Okay, we'll see. It seems to have no issues on Twitch, at least. Let me check. Also, okay, well, I guess we'll find out. Yeah, I thought it was gonna be harder to do, so that's why I said I will do it next time. But it turned out to be pretty easy just to change the number there. But it still says like 6,170. I set it to 6,000, so I don't know why it's like too high there. Okay. Well, anyway, let's see. So now we can call this relative to current working directory. We need an allocator. We need the directory. And we also need a file name. There we go. So there is our relative thing now. And I guess we catch return error if we cannot get it, because otherwise we can't really do anything there. Okay. So now we have a way to get the relative file name. That's very nice. Excuse me. All right. Anyway. Okay, so yeah, great. Let's try if this works, I guess. Use of undeclared options. Oh, right, I see. Yeah, okay, so we need options, which is gonna be like read file options. All right. Now, why is... Yeah, there's still some issues here. Undeclared file name. Okay, so we need file name as well. I don't think we need file name after that though. Well, maybe we do because we're showing an error message over here. Yeah. Okay. Let's. But that. No. Yeah. That's fine. Let's just store the file name here. But then we need options as well. Let's just store the options as well. Read file options. That's fine. So all of that is in sort of this state here. And I guess we can do an init function. Okay, so we need file name and options. Okay. And I mean, technically we could do the file stuff. We could do all this. Well, maybe not actually, because we need to store it. Well, no, the file does not need to be. Yeah, the file could actually be stored directly there. So we could actually bring this over here and have const file. I think so, because the file is copyable, so we can just store it here. That's fine. However, now this can be an error, so we'll do that. And we also need an allocator now. Okay. Man. Right. So. Yeah. Great. Let's see. Yeah, so the JSON reader. Now these do need to have like the location. So we need some sort of function that we call on this in order for this thing to actually be set up properly. I mean, I guess technically we could call it here as well. We could make this like not this, and we could call prepare here. Although this is not an error anymore. Okay. So we prepared and we do parse leaky. Yes. We have allocator. We have self JSON reader. We do have, yeah, that's right. We do have self options, parse options. And here we also catch our relative thing. Now we do have self.filename. The dir is gonna be this. I guess we could have like okay, we could have on the options get dir. Yeah, that works. Because now we can call options get dir here instead. And we can use it here as well. I wonder if we should show like the error message first, because if there's an error here, we don't really show what the actual error is. Well, we do show it here, I guess, but we don't get this prefix. Ah, whatever. Let's just have it like this. Okay. Excuse me. Relative, yeah, so this would be over here. And I will report the error. All right. Okay, so that is everything for leaky there. What we could do is also we could generalize this. Well, we could put this into a function, I mean. And so like report error. Return anything. This could though become an error, I guess. No, we just return there. Yeah, so I don't think this needs to be a pointer though, but whatever. Let's remove it and we'll see. So we need an allocator, and I think that's it. Oh, this needs to be self. Oh yeah, this is where we call this now. So this would be self report parse JSON error allocator. Is that it? Oh yeah, we need an error as well. So you can pass, you can have like any error, because all errors I think are like the same size. So there we go. Alright, we should have like a couple of issues that we need to fix, because it's not formatting, which is a sign that something is wrong. Options, unused parameter. Oh, let's remove that. Undeclared allocator. Oh, there we go. Let's see. Use of undeclared identifier JSON reader. Oh yeah, this is self.json reader. Oh, so now I think we well, no, maybe that doesn't need it to be a. No, it doesn't need it to be a pointer, so that's fine. Undeclared JSON reader. Oh yeah, this is self.json reader. However, now this needs. Wait. Oh, right. This is this function. Right. So. Right. So now we need to have a read context. And we initialize with allocator, file name, and options. There we go. And now we simply return this read leaky. Well, we also need to do... no, we don't need to do prepared because we're doing it in here. Read leaky. T. Allocator. I think that's it. Yeah. And then we also defer. Deinitialize. Maybe do we need an allocator here? No, we don't. Cool. So now we can remove this. There we go. Now, I wonder if I should make this default or if the other one should be default. I'm not sure actually. Like the read JSON file, or maybe it should be explicit, like if you want it to be like the arena type, or yeah, with arena or the leaky. I mean, it should probably say that. Now you could pass in the options to say, okay, is it gonna be leaky or not? But that would alter the return type, and it would also make options like com time. Well, at least maybe some of the options. I'm not sure if you can have a struct that has some things com time and some things not. Because if some things are runtime, I don't know. You would have to sort of convert it somewhere. I don't know. Okay, let's see. How do we want to do this now? Let's just have two different functions, I guess. So this would be called leaky, and this would be called arena, I guess. And now this is a parsed. I'm just gonna double check the type of this. So standard JSON parsed. Yeah, so that's what it is. It just has that. Yeah, let's see. There we go. All right, and now we need to implement the arena function. So we'll copy this part, and this is arena now. Now we do need an allocator though. Yeah, because we're now just returning this. All right, it should be the same everything else. Okay. Use of undeclared identifier. Oh. Okay, now we actually want to return this because we want to return the error. Oh, there we go. Now get rid of all the compiler errors. Okay, so now we don't have a read JSON file anymore. And this is actually now we need to choose if we want to have a arena or a arena or a or the leaky version. So let's do leaky for this one. Let's also make a GPA here. Wait, how did we do this? dot. Let's check the let's check this. Heap debug allocator. So alright, so we're calling it with a config. That's right. So first we call it with the config and we'll put safety on. And then what else? We return. What does it return? Dot init. Right. Which is this here, yeah. So just dot init without calling anything. It's kind of weird how they sort of make this. Why not, you know, follow the convention of dot empty for other things? It's just the allocator that does this, as far as I've seen. It's doubly weird because init usually is a function, but now it's this for this specific struct. It's a public. It's a declaration. So yeah, that's not a function. It's just a constant. Well, okay. Anyway, sorry. Let's see. So we'll defer the initialize allocator. It's gonna be allocator. There we go. Okay, what's the issue here? Root 187. Expected type root read file options found root read JSON files. Oh, hang on. Oh yeah, it should be read JSON, not read JSON files. There we go. No field, no name, get directory. Oh yeah. So now we can move this. Yeah, let's just put it over here. All right. I wonder if you could do this. I wonder if you can have a function. Let me just cook here a little bit. So you have a function here, get there. Now what if this is this now? Right? Okay, I'm not sure if this will work because this is gonna be, I think it's gonna be like evaluated immediately, but you know, I'm not sure. I think this will refer to the struct of the file. So let's just see. But what I wanted to check was if you could do something like this. Getter is equal to get there. Let's add a little thing there to make it. Yeah. So can you actually call getter now? Is the question. No field or member function getter in JSON. Okay. So that didn't really work. Getter is not a member function. Okay. Is it because of the type is wrong? So let's say that, let's change the type of getter to be something else. Where the hell is this? I mean, what you could do is you could have a function that's like getter. And then you have a type that you need to extend or whatever, and then you get a type, we return a struct. Actually, we could return the function itself. Type is t, return is this. Alright. And then we have a struct. Self is t. This is this. And we return that. And then this is getter. Okay, and then this is getter this. So will this now become some, this would be sort of like, well, we're sort of borrowing this function. Now I realized that what we could do is we could just define this function outside like this as well. Like you could define this function like this, and then this would be, I don't know, and this could be like any type, right? And so then, but then you have to sort of say getter. You have to define it like this now. But it is sort of, it is like possible to do this, which is a little bit, but it's a little bit more involved. Although this is more involved in actually defining the thing, but I would rather have it more easy to use than to define one time. Because this is gonna be where it's duplicated. This part is duplicated. This is only done once. So I would rather have this in that case. Will this work? Alright, missing struct file reader. Maybe those should be like nullables. No. Maybe we don't even need these actually. Maybe because they're only used in the last function. Although we do need to deinitialize, but we could deinitialize at the end here, actually. We don't really need to deinitialize in that case. Well, we do need to close the file, I guess. But the reader we don't really need there, actually. These things, we could actually just... It's just that we wanted to store these things somewhere. So that's the only reason to make this like separate. It's like we could do this, except they need to be var instead. But now we need to copy this logic, so that's why I wanted it to be in a separate function. But now it's like, okay, now we need, could you make a separate struct for this, just this specific, like the readers? Hey, yeah, welcome back to Step. I changed the bitrate to 6000, which was sort of the recommended for, well, I guess it says like up to 6000 if you want 180p. I'm not sure if, like, maybe I should lower it more because I'm not sure if I need that much though. I don't know. Let's see. I'm just gonna try this and see. So I'll just have the reader, and here we have the file reader and the JSON reader. Right. And let's move this in here actually. This is kind of, I mean, the whole problem here is that you can't have a function that returns, that like uses the parent's sort of address. I only see 1080 60 option. Maybe I'll kick in next time we start the stream. Yeah, I lowered the bit rate like on OBS, so I don't know what that does with the, like, I didn't add any other options. I don't know. I was just wondering, like, if there's a reason to have like such high, if it's probably better to lower it if it's not needed to be that high. Like seeing these letters very crisp. I don't know. Stream is fine. Okay, cool. Okay, so let's see. Yeah, but here we also need a file and the buffer. Well, I guess we can just pass in the context. This is all in the effort of sort of not repeating some stuff. It feels like there should be another way to do this, but let's see. Let's make a reader, which is this, and then we say reader. This is just so that we have this reader now on this, in this stack here, right? So that we can say prepare, right? And we need allocator and self. Okay. And I guess we can also add like the initialize. This needs to be public. Like, yeah, I'm using 0.15.1. Have a nice day, Polaris7. Initialize. Now it's only the JSON reader that needs to initialize. There we go. So now we can say defer reader.initialize. All right. So now we can say here instead reader instead. There we go. Okay, but now the issue is here. We actually need to pass in. We need the reader here as well, I think. Yeah. So we actually need to pass in the reader here. But it doesn't need to be a pointer. All right. So you need the reader. There we go. Okay. And then we also the file close is, yeah, I mean, I guess this, no, we'll just do here, file close here, right? How was the upgrade? It was actually pretty, it was a lot. But it was mostly my fault actually, because I was using the main pain point was well, there was a bunch of different things that got updated that I had to update, but the main thing was the using namespace is gone, and I did use that very rigorously, unfortunately. So I had these sort of, I would say, like library files that basically imported everything so that you can more easily access everything, basically. And they were like one of them were using namespace for everything. So I had like pub using namespace import blah blah blah, like all the files. So basically what I needed to do was change that to manually now import everything that I needed to have sort of public in that file. So I needed to sort of change the structure a little bit as well. Also, there was I was using a kind of like mix-in sort of thing as well for the, but it wasn't really meant to be like a mix-in. It was more like it was more like the partial class pattern. Like I broke up a class or a large struct into several files, and yeah, but that was more easy because I ended up just doing this. Here's that file. So basically you can see here all of these regions now that I have here, or folds, or they existed in separate files, but yeah, I just put them in this file directly now instead, and just made like folds for it. So a little bit, yeah, organizational crisis there, but yeah, so it took like, I don't know, yeah, it took a little bit to get it working. But yeah, now it's done, and hopefully there's not gonna be that huge changes in the future. Another thing that changed was the array lists. So now, like, the unmanaged version of array lists are the default. So standard or stud.ArrayList points to ArrayList unmanaged, while before it points to ArrayList managed. So you had to sort of fix that as well. I basically changed all the managed, all the places where I had managed, I changed to unmanaged. So now I'm using, like, because managed is going to be deprecated, so it's still available though, so you can still access it if you don't want to sort of handle that upgrade right now. So you can still sort of use the old version, or yeah, or the deprecated version. But yeah, it's gonna get removed, I think. So, but I did upgrade that. Also, a lot of the packages that I was depending on hadn't upgraded yet. So, and I don't know, it didn't look like there was. Well, I don't know if they were working on it or not. So I forked a bunch of packages and upgraded them to 0.15. So yeah, there was a bunch of stuff. What else was there? There was a couple of other things as well. I don't remember right now. I like using unmanaged. You have lots of passing around allocators, but I find it's not too bad actually. Yeah, I like using unmanaged almost solely for the fact that you don't have to pass an allocator when you initialize, because that messes up the whole sort of initialize flow. It's like the only thing that needs an allocator almost, so that if you have an array list and all of a sudden you need to pass an allocator to all your init functions, if it's like deep down in your thing that you need to initialize. So way easier because you just said type .empty and then you have your list initialized, so that's really nice. And now it's like, it's also, I like making passing allocators visible, because then you sort of know that, okay, something is gonna get allocated here. So like, well, I guess for array lists, it's like it's sort of contained within the array list, so it's not really you're getting a result out that you need to take care of, that kind of thing. But yeah, I like unmanaged versions. I think that they favored unmanaged. I read that the reason for it was because they favored the pattern of where you would initialize an array list unmanaged with some capacity, and then you would use append assume capacity to sort of optimize the append function. So you don't need to check for capacity every time you append. So I think that was like one of the reasons why they sort of favored that version. Yeah, let's hope there's, well, oh yeah, another thing that they changed was the IO stuff. So yeah, and that's why I made this little sort of library here. It's very, very small and simple library, but it's basically the IO stuff changed. So now if you, for example, want to write to a file, here I have a function called write file. Basically, you take a file descriptor here and a format string and arguments, just like, you know, print to a file. And so what you need is you need to create a buffer, and then you create a file writer like this, but you need to pass the buffer. That was changed. Before you didn't need to pass a buffer, you got like a built-in thing, but now you need to define your own buffer here. And then you access something called the interface, which is like the generic sort of interface that exists on all the writers. So this is like the new generic writer, or before they had two different kinds of like generic writer. They had like generic writer and any writer, and also the writer now functions that take a writer can take the standard IO writer type. They don't need to say any type anymore. And I think that's an upgrade actually, because then it's like more clear of what you're actually passing in and what's happening. Yeah, I really like that change. It does, however, change a little bit how you're dealing with this. So now you have to say writer.interface to access the sort of generic writer there. It's not called generic writer, it's just called writer, standard IO writer. And then you can access all the different functions that it has, and you can print it out. And so so it's kind of like the writer. This has a vtable, I believe. So the implementation is, in this case, the file writer. And so it's like, yeah, it works. And then you also, new for this is that you have to flush in order for things to actually happen now. So yeah, that's just how sort of the operating system works as well. It's like you have to flush before they did it for you. Now you have to flush yourself. So don't forget that, because otherwise, as I discovered, if I want to create a file or write to a file, it's going to be created and it's going to be like empty, because that was what I was doing before, like creating an empty file, and then I forgot, I didn't flush, so it was still empty when I exited the program. So that could have led to a bunch of data loss, but fortunately I caught it, and yeah, I wrote this little library to make it easier. But yeah, the by the way, I really like this formatting pattern that they have, because this is very, very sort of, I guess you could say, like scalable to different types of formatting stuff, because it's like, yeah, it's really, really cool actually, because yeah, it's just built-in formatting for everything that you could think of here. If we look at the JSON stuff, like writing a JSON file, you just use the JSON formatter. So that's I think that's really cool. Forgetting to flush is a big code smell. Well, the thing was that before you didn't have to flush. Oh, sorry, I didn't understand at first. Yeah. It is. Yeah, it's gonna stink it up if you don't flush. So don't forget that. But yeah, for my purpose here, I just wanted to, automatically do that whenever I want to do these things. I don't have, I don't have like super large files that I have to stream in or anything like that. It's just, I just wanna do everything at once, and then it's fine. Well, I believe also like it is kind of some stuff, like some streaming stuff is actually like built in here. So so when you actually print this out, it's using this buffer. But what if the thing you want to print is like larger than the buffer? Then it's gonna stream it. So it actually, it is automatically sort of streaming it. So yeah. All right. Anyway, I think that was mostly like the larger changes that you need to do. There was also some like minor things, like in the build system. When you create an executable, before it looked like this. Now it looks like this. You have to have like a root module instead that you use create module like this. That's it. Well, that's one of the change. There was two other. There was like add shared library and add static library was merged into add library, and then you pass in if it's going to be static or shared in an options instead. Changes standard formula also significant. Oh yeah. That's right. That was also, I had to search a lot of places where I had those problems. Yeah, you have to pass F if you have a format function. Otherwise, it's gonna complain. Oh, it's ambiguous. Do we want to use the formatted function or what do you want? But yes, I want to use the formatted function. And it's like I guess I liked how it was before. Like if there's a formatting function, it's where we want to use it. Like I don't really see. I mean, there might be something I'm missing. Like, why would you not want to use the formatting function if you have it? But yeah, there might be something I'm missing there. So some use case. It was just annoying to have to put in F everywhere. Strings are the same. You have to put S. For everything else, basically, it's just this now. I do like how they remove the requirement to put D if you have a number, because that never made sense to me. Because it is a number, so you want to format it as a number. Why would you have to put D there? It's like, why is the default not like, just formatted as a number? So, and then you can have different formats options, but why did you have to put D there? It's like, I don't know. But now that's gone, so that's really good. Yeah. That was, I guess, mostly it. So the big ones that I had to change was using namespace. That was the largest one. The formatting, because there were so many places that I needed to change. The IO stuff was also a bit, because I had so many places where I like opened files and stuff. So especially in the game project, I think I had a bunch of places, or yeah, in the editor as well. So no, especially in the editor, yeah. But now I've made this library so that I can more easily do all that stuff. And I was sort of practicing trying to make a thing where I'm doing some stuff, and I don't want to repeat myself here. Also, custom format functions don't receive comp time format anymore, just write it on args. That was a big source of binary bloat. Oh, okay. Yeah. Yeah. I had some format functions that I had to change, like 3 or 4. Yeah, and those were never used. I never used those things. I guess you could sort of look into, like, I was wondering how they were supposed to be used. Like, you would look into the format and like create your own sort of format or something like that. But yeah, it was too complicated. Hi Con, how's it going? Welcome. Let's see. I'm just gonna grab a cup of coffee. I'll be right back. Alright. How's it going with your project, Con? Let's see. Or with your learning. Yes. Okay, so. So right now I was building this thing here because I had a bunch of code like this that was like, I needed to have them in several places. So I thought, okay, how do I create a function that, or how do I sort of make it so I don't have to repeat this several times? And then I started using these structs things, because what you need some state where you keep the thing. And yeah, I'll move these things. So now I have a struct where these things I need to keep on the stack at the same place, but I need to like, well, the only thing that's changing is basically this part. So here's like the setup part, and then this is the actual part that's gonna change. And so we're setting up this reader thing, which sets up the reader. So that's the context of the readers here. So basically I have to do this just because I don't want to repeat this part. This is the part that I don't want to have to repeat. So I'm doing this here, and then I'm gonna do it here as well. And that's basically, so now I don't have to repeat that part. Okay, but it's like, it becomes very complicated, and it, yeah, I don't know. It's I'm sort of just practicing this pattern where I don't have to repeat these things over and over. And the main problem is basically that you can't have a function that returns that wants to use like addresses that you return addresses, because they become sort of relative to the stack frame where you call the function. So you can't return something unless you can use some sort of trick there. I don't know. But that's the whole thing here. I think Andrew has become more conscious of using comp time params. He said for quite some time that standard format needed a rewrite, and he just kind of ripped lots of stuff out this release. Standard FIFO, IO, counting reader, writer, lots of stuff just gone. Yeah, I think standard FIFO, the thing with that was there was a thing they call like the ring buffer, which is, I guess, the technical term for whatever that thing was in standard FIFO, and they had a bunch of basically copies of that in the standard library, like 4 different places, and so they just merged them into one, and it's, I don't know where it went, but it's like, we'll read up on the ring buffer in the latest release. I never used it myself, so I don't know about it, but standard format need a rewrite. Okay, so yeah, I mean, it wasn't changed that much. I think the pattern is nice. FIFO will replace by standard DQ soon. Peer on the way. Okay. I thought they did something in this release. Ring buffers. There are too many ring buffer implementations. Linear FIFO is removed due to being poorly designed. Is removed, so it's removed in, I guess, 0.15. Yeah, I don't know. I never used these, so I don't really know what it's doing. Okay. Let's see. Yeah. Okay. So basically, these two functions, read arena, read leaky, they basically do the same thing. The only thing that's different is this function here. So I'm trying to capture all the common functionality in these lines here and this line here. So, yeah. So then, mission accomplished. I don't have to repeat myself. Oh yeah, I also messed around over here. So, oh yeah, that's the thing. I wanted to check if you could actually create sort of, not really a mix-in. This is more like you can create a function, a member function, doing this. But then if the member function is sort of common among several different structs, you can call this function with this type, and then this type will be replaced over here. So this will become sort of like a member function. And then this is now a member function here. I hope, at least. I'm not sure if it works, but well, I'm just experimenting here. Oh yeah, so I think, yeah, try. Okay, so now read leaky is sort of self-contained. We don't need to like deinitialize anything. We do need, well, no, because, no wait, because we're initializing here, I guess. That's right. But we could move this into the prepare function though. Yeah. But then here we need now we need to store the file over here now. Well, no we don't. Actually, we can say this. So now this could be an error. I think all changes were for best. Sig is leaner now. Yeah, I think it's there are good changes there. It's a valid way to make a member function. Yeah. I'm not sure if it's a good pattern, but at least if you have like a common functionality there that you wanna share between structs, then it is possible. I mean, it's also possible to just define a function that calls another function, but you know, it's a bit more text, and you have to specify all the types and stuff, signature and stuff. Let's see where. So we don't have file there now. We have it here. This needs to be a pointer. It is. And this can now be an error. Fine. And we have the initialize on here. So we will also do. Well, we could move the file. We can move the file over here actually. Fine. Yeah. So this would be self.file. Alright. And we'll close this there. Okay. So now we don't need to do this. We simply do that. But here for prepare we need to send in. No, we don't need to do send in anything. That's just because you don't. That's just because you're not used to it, Con. As with any language. Alright, let's see now. Where are we at? Unused function parameter. Yes, good. Good. This would be context options. There we go. $2.15. I can read other languages though, not this. Yeah, I mean, that's probably because I mean, yeah. If they are there are many languages that look exactly like C, or I mean this is very close to C though, but it's it has its own quirks and stuff. But I would say also like the more experience you get in program languages, like different types of program languages and experience in general with program languages, you will sort of understand, like even though you have never seen the syntax before, you sort of know the concepts, so you can sort of figure out what stuff means even though you don't really know. Now if there's something that is like very out of the box or whatever, then of course you're gonna have to learn about it. And but I feel like if you're well traversed, there's a lot of stuff that you can sort of figure out, you know. Let's see. Regions. Wait, what's the issue? 2 arguments found, 1, 3. Yeah. So we don't need to initialize. Or allocator there, I mean. No field number named leaky. Really? Oh, right. Wait. No, you cannot be an error now. There we go. This is lower level than C, and syntax is harder, so where is the similarity? The similarity is in, you know, the parentheses, the curly braces, the sort of structure of the whole language, basically. But then, you know, there are different keywords in Zig. You have defer, which doesn't exist in C. You know, these things are the same, like accessing, you know, writing dot something to access things there. I guess that the one thing that doesn't exist is this, but I do welcome not having to sort of know which one. Sig does figure it out for you, so you don't really have to worry about the arrow rotation. Or whatever it's called. Which, after you get used to it, okay, now you know what's happening. So, in the start it was a little bit confusing, but you know, for the most part, you don't have to. Well, dereferencing in Zig, you do this, but you really don't need to do this ever, unless the only point where you need to do is if you need to populate a pointer's content with something, then you need to do this. But otherwise, you don't need to dereference, basically. Or if you need to pass the constant version of something into another version, another function. Okay, yeah. Here's the let the wars commence. Yeah, if you have like a pointer to a pointer, yeah, you do need to do. Yeah, that's true. I usually never have that, but that is true. Let's see. It auto derefs one pointer. Yeah, I mean it kind of makes sense, because then it becomes kind of ambiguous, I guess, maybe what you want to do. I mean, technically the pointers doesn't have like functions themselves, so it kind of can be something that it could auto dereference if you call a function on the thing, but maybe it's good that it's clear that it's like a pointer to a pointer as well. I don't know. Misinstruct field file. Oh yeah. That is correct. Let's set this undefined. No field name file in that. Yes, because I moved it there. Reader error union is ignored. That is correct. So if there's an error preparing, we should return that error. So we should just do a try. Also, if there's an error, let's see. After the file is opened, well, that's the only error that we can have, so I guess that's fine. Yeah. So we don't need to, we don't need to close anything or clean up anything here if there's an error. All right. Now I do think this struct is kind of a mess. I wish there was a easier, more cleaner way to do this, but yeah, that's the way it is. No field member or function name report JSON. Oh, well, this is. Oh, this is read JSON context. Okay, so this needs to be a thing there. Fine. 216. Whoops. Yeah, so now we don't need to deinitialize here. So great. One extra line gone there. So basically, it's like because the whole thing here is like these two functions are basically the same. It's just a tiny difference. So what I did was I extracted a lot of functionality in this struct to be able to have the same sort of, because this is the location from where you call this. So this is where sort of the this stack is where the location is. So that's why you have to do it like this. Well, unless there's another way, which I'm not aware of. And yeah, it's basically just creating space for this place to be. And then we also have this reader, which also is the kind of the same thing really, but for different things that's needed over here. So here we have read leaky, which basically read leaky and read arena does the same thing, except this is the leaky calls leaky, and arena calls just this function. So that's the only difference, and that's why we need to encapsulate all this there, just so that we don't. So this was an exercise in not repeating ourselves here. So this is what it's mainly doing there. We're preparing a reader, we're parsing with using that reader from the file there, and then if there's an error we can also report it using this function here. All right. Okay, cool. Does it work now is the question. So yeah, it seems to still work. Great. All right, so now we have a couple of places where we use this, but now we have to say if it's gonna be like leaky or if it's not gonna be leaky. So here, for example, we are loading a project options, which does not have any allocations in the file. So this is fine to be leaky there. And then save. No, that's not. Here we have another thing. So this one could also be, well, actually no. This one is actually where we need an arena. But now we can get rid of this one, and we can instead say that this is the parsed value. So you get an arena from out here, so you can call the initialize on that. But then the editor session, we can now get the value out of the parsed like this. All right. And this part, well, this needs to be, well, I think it's fine if this is leaky, probably. We're gonna figure out if we're gonna get any leaks. But if it was leaky before, it should be fine to be leaky now. It's just the part where I needed to deallocate directly. I wanted to have it as an arena. Okay, so let's see if this works now. I usually get some compile errors, but maybe not. One setting context. Use of undeclared. Oh yeah, so now this is self-allocator instead. Whoops. Oh wait, now we have a problem here. 221. 2 I must found 3. Oh yeah, this doesn't need allocator. Okay, there we go. Okay, do we have more problems? Prepare. Error union is ignored. Oh yeah, we just need to try. No, JSON root. Oh yeah, this is reader.json now. Okay. Catch error. Wait, what's the issue? Expected type, blah blah blah, found, static parsed, huh? Okay, hang on. JSON parse from token source. Yeah, it does return an error, of course. So what's the issue? It expected an error type and found okay, yeah. Okay, so the return type here is wrong. This should be JSON parsed. There we go. Uh, 172 expected. Okay, 172. You want. Well, let's just do this. There we go. All right, that seems to work. We can read. If we quit and enter, this should all still work. Okay, cool. All right. C on its own is clean. There are 2 languages I have to learn, C and the macro language. Yeah. That could be that can be a bit tricky. I'm not saying that the C comp time stuff is easy either. It's just that it's more structured, I would say. It's like, yeah, it's I mean, and then you can do stuff like you can loop through the fields of a struct and do stuff like that. You can sort of manipulate the names. You can create new types depending on the previous type if you want to do that sort of thing. So there's a lot of nice things you can do with the comp-time stuff. I will say though, it is a pain that the LSP doesn't work fully with it. It can't sort of realize all the types in comp time, so sometimes you don't get help from LSP with that. I wonder how it is for LSPs with C, if there even is a LSP for C. I guess there is something, but I mean there has to be. I know there's like linters and stuff like that. Yeah, the Rust macro language. As far as I understand, it's also kind of like generating code using almost strings that are sort of concatenated. Like, I don't know, but it kind of reminded me of in Haskell. There's also like template Haskell, where you're basically reading in a string that is sort of the input to the macro, and then that, because you're sort of defining new syntax, so you have to sort of define your own parser and create code based on that. Let's see. Okay, so what now? This question. Yeah, I was checking if I had more references to these things. So create file. I shouldn't really have any references to create file. Okay, here we go. So here's one place where I haven't done this. We have a file name and the directory. Yeah, and then we open the create the file. We write. Oh, we just write this. Wait. Now here we go. We're doing this serialized thing. Okay. Now the thing with this function is we call this function. It essentially just calls, you know, format JSON. This is the same for all functions, for all the documents. So really we could replace this with something else. So we could really where was that? Create file. We could just replace all that with write JSON file. One second here. So don't get the things. Oh yeah. Anyway, first is the file name, then the data, which is gonna be self content document, I guess what we could do is we could say get persistent data. And we don't need a writer. And this. Okay, so the type is okay. This is gonna be okay. It sometimes feels here like we're sort of inverting things. We can't just get, well, we can do that, but the type is gonna be sort of depending on this value. So it would be nice if you could do this, but then we have to know the type, or we could have like pointer to any opaque or something like that. I mean, we could also say switch now it's gonna be d.persistent data, that's right, I think. No, it's gonna be document persistent data. There we go. So that is now the persistent data. Now this has kind of a weird type now. It's like it can be several different types. So I'm not sure if this actually works. Maybe this needs to be like a pointer. But then, can we even dereference it at this point? I mean, maybe it doesn't matter. Maybe we can pass a pointer here. It doesn't really matter. And yeah, and then we need what? Options. That's right. So the directory is the root. Okay, and then we do just a try, and now we can remove all this. All right. Yeah. Okay. Incompatible. Incompatible types, const documents, persistent data scene. Okay. What if we? Yeah. So if we have it as anopaque, there's gonna be a problem over here. Yeah, this pattern didn't really work here, so I'll just go back. Yeah, that's fine. Sometimes it doesn't fit. It's just a little bit annoying you have to do all this stuff. All right. I mean, maybe. No, whatever. It's fine. Let's see here now. So we have create file. Do we have create file in a bunch of places like these guys? The tool thing. Yeah, that's right. Okay, now here. But here we actually want to have the writer available, so yeah. I was also thinking about like encapsulating this stuff in some sort of struct and stuff, but yeah, it that's fine. Okay, so great. Let's see, does this still start up? Fine. The gamepad still doesn't work. I don't know what happened. It's like the keyboard works, the input. It might be something to do with the new code actually. I did do some stuff. Yeah, I'm sort of first looking for a gamepad that exists, and then I'm setting this to that gamepad value. Let's see. Yeah, this is the code that's run. So I'm not sure why it doesn't work. Because it says that it found it. Let's see. Where is that? Update. Yeah, if it's null, we're checking for. Yeah, and normally Raylib has this thing set to like you can only have 4 things, and then we're just checking. Okay, is one of them available? Then we set it to that first one, and then we break out of this loop here. And then we should have the gamepad set at that point. And we do get the found gamepad message. So not sure what's going on there. And even if we don't find it, we set it to 0, so yeah. I don't know. Because the keyboard works. Now this is what this was before. I just forced 0 for everything, and then it worked. because I guess that was my only gamepad connected. Nope, now nothing works for the gamepad. And just to make sure the keyboard works as well. Yeah, keyboard works. And I did get the message, right? Yeah. What the hell? Hang on, did I change something here? Like, if this is down, then return true, right? So if this is not down, we fall through and check if this is down, then true, yeah. So it's not like I'm just returning the keyboard. Yeah. It's an OR here. And that's really strange because just putting 0 worked before, so I don't know if there's an issue with my gamepad. It does seem to detect it, but then nothing really shows up. So I'll do a test here. If it's pressed, we will log. No. Well, actually, let's do. We can even do this. Because the name is the same, so we can actually do. We can do enum from string to enum. Type is this, I guess. The string is tag name of your input type. So if that is down, we do a debug. Or if it's pressed. Tag name. Type. Pressed. I think it's called released. We will find out. $173. What is your issue? Oh, if there we go. Now the colors popped in as well. Let's see. 172 expected type I32 found. Oh. Let's do this. expected type. Gamepad button found. Question mark gamepad button. Okay, I'm just gonna say or else unreachable, or we can just do this. So maybe we'll know if things are being pressed or detected. Nope. It says it found it, but it feels like there is something wrong with the code, because it has worked before, like flawlessly, and it does detect the controller, so I mean, it feels like this should work, but it doesn't. The only difference is basically this code here and saying that, I mean, it's basically checking for this. Okay, let's just set this to 0. No. Well, now we don't get the message, of course, because I removed it here. Okay, let's do this then. No. Man, what is going on? I mean, I know it goes in here and calls the functions, because otherwise the keyboards wouldn't have worked. So yeah, this is strange. Hey, Micon, how's it going? Good morning to you. Well, for me it's like 12 o'clock, but yeah, I felt good enough today to go on stream, so I'm still a bit I don't know how to call it. I still have a little bit of symptoms, but 11 a.m. in Ireland. Oh, okay, cool. Okay, yeah, but I was looking into this issue with the gamepad. It's kind of weird because it used to work, now it doesn't work anymore. And what I changed was this. I think I'll just try and change this back. This doesn't make sense to me. No. Let's see. So we'll do this. And I'm thinking of yeah, going through your project a little bit today, if you like. I've looked at it a little bit. Let's see. Unused. Yeah. Okay. No, still doesn't work. Great. So I don't know what's going on there. Maybe it's something weird. Maybe it's something with my controller. Maybe I accidentally changed, because it's like a third-party controller. I can change sort of the type and stuff with it. So yeah. Maybe I pressed something weird. Sometimes gamepad gets two IDs because of some drivers issue. Okay. So ideally I would look at the thing that is being pressed right now, I guess. Maybe I should have one state for each gamepad. Gamepads. So this is the main gamepad. We'll have a thing here. Let's do like max gamepads. And Raylib has 4, I believe. And these are yeah. I mean, I guess this is like the ID of the. It's really just an index into their little array there. But let's just do this. No. Actually, would this be a list to nulls? Okay, this is gonna get annoying. Actually, I need a bounded array here. Which I do have, I think. Or do I? Yes. Because I don't want to allocate this. Okay. There we go. Yeah. I'll just try and fix this real quick and we'll look at that. Let's see. Game Pass. Yeah. Alright, see you soon, two-step. Have a good day. Let's see. Alright. Okay. So I want to do this, I guess, all the time. Maybe it's maybe I don't want a bounded array. Maybe I just need an array. Actually. Check available or update available gamepads. Alright. If it's available. We don't want to break. We don't set our gamepad. We say gamepad I or I is equal to that, sure, whatever. Found gamepad. Yeah. Okay. Standard, can you know standard mem 0 init as -1 static vector instead of array? Initialize all field of the struct with a wait. I think wait, so init 0 values if no default values present. I think this is for like a struct, maybe. But I guess it might work anyway. If the field is present. Okay, so you're saying like initialize with -1. Oh yeah, this only works for structs, it seems. But there should be... No. But what you can do though is this. You can say no, wait. Max gamepads. You can do this. And you can say null times max gamepads. So this would be filling out the thing these many times, or it will sort of, yeah, like concatenate this into a larger. Yeah, it will do this four times. So however many times this will be. So this will result in, since this is 4, this will result in a list with, or an array with 4, but I don't need an ampersand there. This will be an array with 4 elements of null. So that should work. Let's see. Yeah, that's fine. I guess if it's not available, we also want to set it to null. And we can also play a little message. If this is not null before, if it wasn't null before, then the gamepad was disconnected. Gamepad disconnected. 1 second, why are you not getting this info from Raylib? Or are you not? I am getting it from Raylib. This I'm calling Raylib. Is gamepad available here? So Raylib has. Well, maybe there's a better function. I haven't looked into that. Actually. Wait, where's... So I'm using this function. Because like every function that has like is gamepad, is button press, blah blah blah, it takes like this int gamepad. So you have to sort of check. I guess you would have to check the gamepads by looping through the different integers. So, and I've looked into the code for Raylib gamepads, and basically they have an array with the maximum amount of gamepads is 4, and they have this array that goes from 0, 1, 2, 3, 4, and that's where they have like their gamepad state, and this int is basically an index into that array. So I'm just looping through 0 to 4 to see which gamepad is available. It's not really ideal. I think, I mean, I would rather have like, I don't know, I guess some sort of event that you listen to or something like that, and that you get an ID that you can use or something like that. But yeah. Or I mean, an index is fine, but something that is, that you know, okay, because Raylib doesn't really tell you how many gamepads you can have. Like it just, you can just call this function here. Unless I'm missing some other function somewhere, but yeah, I don't know. So I'm doing it like this. I'm looping through. This should be max gamepads here, which really comes from Raylib with 4 there. And I'm checking if it's available. If it is, then we should only display this if this was not available before. Then we display this there. We can say the gamepad connected, gamepad disconnected. There we go. I don't know. Do you have an idea of a better way? All right, and then my idea is that I would keep, so this array tells us which gamepads are connected. This is the current sort of main input that you're using, I guess. Now the issue here will be that if, let's say, someone switches controllers, it could get stuck in some sort of state in that case. Like if you're holding down the button, then switch control to something else. I guess it would be like if it's released. Because my idea is that I would switch over to the gamepad that is currently being pressed, basically. So let's have a function like update current gamepad or something like that. Well, how would this work though? We can't really... You would have to look at all inputs, I guess. Yeah, I guess we would have to look at all inputs from all controllers all the time in that case. And this would also change. Then this would be, we also need like the gamepad as well, right? So we pass in the gamepad instead. Gamepads I or else continue. So if we have if one gamepad is connected at that thing, we check it. Otherwise, if it's not connected, we just continue. So we're looping through this 4 times, and then we're checking if something is down. Then we can break or even return if it's down. We will return, and we will also set this .gamepad to gamepad. There. Right. So we're looping through all the connected gamepads. We're looking if any of, well, this could be up here. If any of the inputs are down, we will, okay, we'll detect that, okay, you're trying to use this controller, so let's switch to that controller, and then we return. Now it does mean that we have to do this several times, but we might not even have a gamepad though. This is like, it's also like gamepads are not the only types of inputs. This is gonna be, we're probably gonna need to like generalize this later into being like, okay, do you want to use the keyboard or the gamepad or something else, you know? But I think for now I'm just gonna keep to gamepad. So we'll do gamepads. No, gamepad. If we don't have a current gamepad, I guess we will just take 0, because Raylib doesn't crash if you just pass 0, and if it's not available, then it's just gonna be 0 everything. So that should be fine. Now we can pass this in here. We should also change no, we don't need to change anything else, I don't think. No, this is the only function that should be changed there. Okay. Yeah, because now we can also detect like keyboard is also detected in here. It's kind of built in this, like, yeah, it's reading both keyboard and gamepad in this function. That's what I was trying to say. Okay, so what now? Well, we are updating available gamepads, yeah, and then we should also update current gamepad. There we go. Alright, so let's see what kind of messages we get now. If it's like, how you're saying there, which makes sense sometimes if the thing gets, it could also be like the thing gets connected and then it gets disconnected somehow. I don't know, it might be the controller is trying to connect to something else and it like switches or something like that. But now I think we should get more information at least. Oh yeah, this needs the gamepad there, yeah. Okay, it's taking longer, so it probably means it works, or compiles at least. Okay, so the controller still doesn't work, but was it connected? So it was connected and then nothing else, so yeah. I guess we can also have here gamepad current switched to gamepad that. So I was sure you can get a list from Relief. Yeah, it would have been nice, but maybe if you're using the C version, you could sort of get to it somehow more easily. I don't know, because there is an array somewhere that you could get it, but I'm sort of storing. Well, I know they are storing the state if it's available or not, so I'm simply storing it as well here. I know that I'm duplicating a lot of the state that's already in Raylib, but I'm doing it. Well, one reason is that if I want to switch out from Raylib, I can, I already have this sort of thing, but I do want to have this sort of mapping system if I want to have a way to sort of remap the things and stuff as well. But yeah, it's just easier to have like control of everything, and there was one specific reason why I needed to have it like this though. Oh yeah, it was because I wanted to sort of I wanted to have a way to consume the state, so that once I've looked at the state in one function, I don't want the next function to look at the same state and see like, oh, this is pressed this frame. So and I realized that could be fixed in other ways, like having other state or updating order or something like that. But this felt like a good thing to do, even though the state is already in Raylib. But as I said, if I want to switch out from Raylib, that's going to be more easy now as well. But anyway, it wasn't that big of a deal anyway. But and now I can also speak about this. This whole system is like I can talk about the input types, which are sort of like actions that you can take, and these are mapped to different buttons. So I'm saying like, okay, is the accept button pressed, which is kind of nice to be able to do, and then here it's mapped to some sort of gamepad button here, which if you want to implement some sort of mapping system and a UI and stuff where you can remap in the game, then you could change the values in here to do that. So it's kind of like also like the beginnings of that. Okay, let's see if we get this. I mean, I'm gonna guess we don't get this since it doesn't seem to register any button presses here. It feels like it is connected to the PC at least, because no, switched. Yeah, it doesn't it doesn't register any button presses, which it has done before with this function. It's just that I changed this to like a dynamic now instead of just having 0. What if I try to press another button? Will Windows... Because it's like if I press something else, then Windows like opens Steam or something. I don't know. Okay, it doesn't seem to do that anymore. Yeah, maybe it was the sort of type of input that got changed. Because this controller is able to sort of change the type of input. I'm just gonna look this up real quick. It's an 8-bit do, it's called. Change controller mode. Face button. Turn it off and... Okay, let's do... I don't remember which mode that I... Okay, let's do X input, so press the side face button and start for the next input mode. Okay, is that correct? It might just be my controller is... No. Start. I assume they mean like the power thing, power button. Yeah, I don't know. Or maybe it's okay, X. No, because I didn't change the I didn't change the thing. What did it say now? Connected? Okay. It says the same thing. Ultimate C. Try another game? Yeah. Press and hold home or switch between... Okay, so you can switch as well. Like if it's already connected. X home. How long do I have to press? Okay, it turned off. No. I'm gonna try the other mode as well. Doesn't Windows also have like some sort of device thing like gamepads, settings? Man, the search thing in Windows search bar is so bad. Unless you type the exact word that you're looking for, you don't find it. It shows a lot of like garbage. Gaming, game bar, controller and keyboard. shortcuts. Captures? No. Okay, yeah, I'll try opening up some game here. Let's see. Come on, Steam. What's happening? Actually, let me try again now. No. Why is Steam not working? Please open up Mr. Steam. Okay, hang on. Let's see if this works. I'm just gonna try get the controller working here. Gamepad. Like it. Why? Video game controllers. It's not even in here. So weird. Where in the settings do you find gamepads? Windows, settings, gamepad. Like I know there's a way to see like the inputs, like the raw inputs and stuff. Here we go, Pro Controller. Yeah, it's not reacting in any way. Okay, so apparently, yeah. Okay, I'll check if I need to change the mode somehow. Let's see, where's the browser? So here's my... The 8-bit do Ultimate C control. This is the control I have. Hold down the X button. Oh, this is like the AI, but... and the home to switch to X input mode. And how long do you have to press? Because nothing happens. Powered off. Okay, so I have to power it off. And then X plus home. Okay. But it doesn't work. I'll try plugging it into the computer maybe. Maybe there's some, maybe it's like connecting to something else. I don't know. And if I connect it with the... So it might just be, you know, a problem with my gamepad. It might connect to my Switch or something. It's not connected correctly. Okay. Okay, you know what? I'm not gonna do this right now. I'm gonna try and figure this out off stream, I think. I'm gonna go ahead and look at your project there, Maicon. Let's see. Yeah, this didn't... Well, we can have the thing here. Yeah, so let's see. So just to say here first that I don't feel comfortable in, you know, I'm not gonna have like a super experienced opinion with Zig, but I have been programming for, well, it's coming up to a year actually now in Zig, not like full time, but you know, so I have been gathering some experience with it. And I played your game actually also. It was pretty nice. And yeah, so let's see here. I was looking through mostly the physics at first. So I was looking through like how did the physics, because I was interested in that because I made also like my own like physics engine for the game, and it looks pretty good. One thing that I did notice is, and this is just like I'm gonna sort of nitpick, so don't take things too harsh. Well, it was this like casting which is being done on every access to this. I'm not sure how much this costs. I mean, it's casting from a signed to an unsigned essentially. There might be some conversion going on there. So, but I mean, it's not really gonna be a huge deal. I don't think. But I was thinking like, okay, couldn't you change like the ID to be like a U size instead, But then it's like, okay, where does it actually matter when the ID is not initialized and stuff like that? But you know, it's not really a huge deal. But that was one of the things that I noticed just going through, and but yeah, looks pretty good actually. So let's see. I was just seeing if I could see something that is solely, because you seem like very sort of experienced when it comes to programming in general. So I was just seeing if there was something that is specific to Zig, maybe then that could be sort of, well, this is a pattern that maybe works good in, or is used in C, but then maybe it's like converted into Zig, it would be more like this or something like that. I don't know. Improve it if needed. Let's see. Yeah, checking collisions. Yeah, this was the brute force thing that we were talking about, right? So we're checking collisions, so we're looping through the collision, the bodies, and then the other bodies. Yeah. And there was some optimization here that you don't need to do like a double loop. I don't remember exactly how it worked. I do have it in my brute force thing though. But you might also have it as well. I don't know. Also, it's also interesting in Dig. It's super easy to get these sort of a lot of nesting going on because of the different switches and, you know, if null, stuff like that, the for loops. Yeah, so that's also when it's like, I usually don't mind it getting a little bit nested because that's just the way Zig is. But now I've started to sort of get a little bit allergic to that, especially since when I program on stream, and so I have very little space on the screen. So as soon as it gets like maybe 3 nesting in or 4 or more, I usually try to sort of make a function for it. Well, I at least that's what I have in mind, at least. Which you could do here for example, here is like switching on something here, the shape, and then you have another shape. So you could, for example, move this into a function that is on the shape itself, let's say. Oops. Like, because the union, you can have functions here, which is nice. So you can have functions here that does the thing. Now notice the pattern here where you basically have no logic on the structs, and you have the function. This is where all the logic is, which also is a nice sort of separate of concerns, I guess. But you could have functions here that operates on excuse me, sorry, that operates on this. So you could have like a pub, maybe I should have cloned this actually. Hang on. Where was it? I'm just gonna see if it makes sense. So for example, let's see up here. So what you could do is you can have a function. Now what was that? Switch on something shape. Here, for example, you could have a draw function. So actually, what you could do, if we start at this one, you can have a function called draw here, which does this. Physics shape circular, and we get a position. What is? Yeah, I think this is like a really vector, and then a color. Okay, and if the interface is the same, this would be self radius. For the other thing, polygon. Well, here it's not really the same interface. We don't have a position, I guess. We have only the shapes. I guess maybe the points include the offset or something. But you could have. You could do this if you want. It's like a different type of pattern, I guess. So let's do this. And if you can still have the same shape of or same signature, except self is now polygon. Now what you can do at this point, you have these two types that has the draw function that looks exactly the same. So what you can do is you can define a draw function here, which takes a union. Did I forget the return type? And what you can do is you can do switch on self, and then you do inline else. So this captures everything, and then you get the underlying shape there, and you can call draw, and then position and color. Like this. So now you have basically like a generic way of calling draw on this shape here. So it will go in, check which type this is, and call draw on the subtype. And let's see, and now we can change, where was the draw? Here. Now you can just say body dot shape dot draw and position and color. Now we can remove this. Okay, it's like I guess it's like a different way of sort of storing the logic. And you know, it's really up to you what you prefer there, but yeah, I'm just showing that you could do that. Now the upside would be that, okay, if you want another union or another type of thing, you can add it here and then just implement the draw function on that type, which becomes very, well, I guess coupled to that thing, I guess. I don't know what to call it. I did not know that I could add methods. Yeah, I didn't know that first either. But then I was like, wait, but you can add. Yeah, I think I don't remember how I figured it out, but I think maybe I saw an example or something. But it's really nice, and you can also do it on enums as well. You can actually add functions on enums. So you can have like a function, I don't know, name, get name. So you can have functions here as well, which is also pretty cool. If you want to sort of, maybe you want to classify different types of enums or something like that, and have it sort of coupled to this directly. Now it is a bit different because it's kind of like mixing in logic into the structs that before didn't have any logic, so it's kind of different, but it's I don't know, it's, yeah, as I said, it's kind of up to the developer what to do there. I'm not gonna say any one is better than the other. I'm just showing like it's possible to do it like this. One would argue that having the logic in one place is better because then you can go here and you can see everything here. But then again, you can just, okay, we're drawing the shape. It's pretty clear what's happening here. You don't get all the different cases and everything. And then you can, if you really want to see what's happening, you can go into here and you can see all the different draw functions, all the different things. Yeah, and then you could do, you could do the same thing for here, for example. You have this different. So basically, anytime you have a switch like this, you could do that kind of thing. However, maybe for it's also becomes an issue like, okay, where do I find the configuration for different things? So that's also it. Sometimes it's nice to have all this in one place so that you can easily change things. If something changed, you can easily go in here and change it all because it's all in one place. So it's like, it depends on really how, I guess, from case to case what you want to have. But for this, for example, collision, I would think that it would probably be a good fit to move this collision things into the shapes themselves. Probably. Let's see. Yeah. Okay. We can quit out of this one. We can continue here. I'm migrating a lot of methods to inside structs, but I did not finish yet. Okay. So you mean like structs that... okay, so functions that was outside, but... So are you migrating like a C project or something like that? I just need to keep it not accessible from outside, but I know it's possible. Yeah. Well, you know about public functions. You can have public functions or functions that you can call from outside. Well, if you don't have the pub keyword, it's like a private function that you only can call from inside the struct. Oh, set exit key. I didn't know about this. This is good. Probably good to have in the real if you wanna release the game, so they don't exit the game by pressing escape. Yeah, this is nice. Although I'm kind of getting used to pressing escape now because I don't have any other way of exiting. But I could. I'm gonna copy this. I'm gonna steal this line of code and put it in main. You can set to only in debug mode. Oh, I see. Okay, so maybe it's only in debug mode then when it does that. Okay, that's cool. Set window min size. Okay, yeah. I was just checking how you set things up here because it's interesting to see how others do it as well, so you can learn a little bit, take a little bit from wait, testing ref all declarations. Oh, so this takes everything here and runs the test, I guess. I didn't know about that. Probably in that SIG tutorial or something, man. Gets all the tests from the imports. Okay. Cool. All right. Actually, I don't have tests, but I probably should have tests. But yeah, physics test. Let's see, game controller. Oh, game control. I was thinking like a input controller. This is like the this is the main actual game. Like we're controlling the game with the logic. I was thinking like game input pad. But yeah, that makes sense. Let's see, games. Yeah, okay. So what? How does the menu work? Game menu. Where is that? There. All right. Cool. Get an image. we're drawing on the image. Control texture. Okay, so it's like some kind of image we're initializing here, and the font. Yeah. Yeah, as I said, it's nice to read someone else's code because you can take from it and learn from it as well. Touchscreen icons. Okay. So does it work on mobile as well? That's cool. Is key release escape, game state, pause. Then it's okay. Touchscreen. Oh, okay. Action button. I mean, I can see this word being here twice. Is this an actual word? Or is it supposed to say button? Or bottom, or... Sorry, it's just I've never seen this, and it's... I thought at first it was like a typo. Okay, misspell. I was thinking about it because now I see it like three times in different places. I was thinking, wait, am I crazy here? Action button. Web version works on mobile. Oh, nice. So the button is a vector, and this. Oh, I see. So it's like a thing on the screen that you touch. I see. Oh, this is pretty nice as well. Get screen to world 2D of the camera. I actually never used this. I used like I take like the matrix from the camera and like inverse it and then do a matrix transformation. I guess this is doing the same thing, except it's much easier to just call this function. I didn't know this existed, so that's a good thing to learn. Yeah, okay, cool. So it's like a function that defines the thing. Yeah, cool. Wait. Okay, so if one of the touch points, so if you have several points that's being touched at the same time, okay. Okay, that's kind of cool. Draw frame, yes. To be able to turn and accelerate at the same time. Oh, nice. Right. I was never a fan of, the touch screen controls for anything, basically. Because it just feels so, like when you glide the fingers and you don't get a tactile response of where the button is. But, I mean, I guess if it's the only thing you have to work with, then you have to have it. why is it not going up? Okay. Let's see. Yeah, so main menu, UI text, bottom, no, button, rectangle. Sorry, I got I was thinking of bottom like it's being rendered on the bottom or something, but then I realized native center Y height width height. Okay, so you have a rectangle. Oh, that's the button. Okay. And then you also have text. I see. Okay, so it's like the same thing, but with text, I guess, right? So this is also interesting because this is like the same idea of immediate UI test, like rendering, except in the libraries that I worked with like immediate GUI, but this is way overkill for what's actually needed. But then you create like it's not actually rendering at the point of where you call the function. But I mean, if it's not necessary to do it like that, then I guess it doesn't matter. I just wanted to point out the difference there, but also the likeness of it. Or this becomes sort of the same idea or the same like pattern, I guess you would say. Okay, so cool. So yeah, the controls just appear with no joystick connected. Okay, cool. And this is for the menus, yeah. Alright. And here's a game over screen or the pause screen. So we draw a rectangle, a black rectangle across the screen. Now this is this is what I found annoying with Zig and Raylib in particular, is the casting of the integers and also the floats. It's like, yeah, it's very explicit in Zig. And since Raylib, for some reason, uses integers for the screen, well, I guess it makes sense because you don't have like half pixels on the actual screen. But it, as a consequence, the casting here becomes really apparent. I guess it's a good thing if you really want to optimize, because you know that, okay, something is happening here, you know. Under the hood. But it's just a little bit, you know, a lot of things to type out sometimes. Also, it's like when you draw on the screen, like some draw functions take integers and some take the vectors that are float types. So you have to sort of convert sometimes. Could be saved already casted. Yeah. What I'm doing is I have a screen. I mean, yeah, I have a screen. Yeah, I have what you have. I have basically a screen struct that has some other functionality as well. But it's basically just the size of the screen. But here, draw rectangle, I think there's a version where you can put a vector in instead. But I'm not sure actually what is more optimized. I mean, in this case, I guess it doesn't really matter that much. But there is a version like draw rectangle V, I think, maybe. I don't remember. I also have like convenience function for like converting stuff to Raylib and from Raylib and stuff. But that's because I'm using my own vector library, or yeah, I wrote my own vector stuff. Because Zig has now Raylib does have nice vectors, but Zig actually has like vectors that are built in that you can use plus and minus and divide and stuff. So you get those like nice expressions if you want to have that with Zig. So at first I was also like using the Raylib stuff, but then I was like, wait, I should just write this because it's probably not that. You get plus minus, like the basic arithmetic you get for free, and then you can also call at max, at min. You get all these different standard functions that are built into Zig that you can just call on vectors, built-in vectors. Not for free. Sorry, which one did you talk about? You have as well from the binder. The vector 2 from Melee Zig has functions. Yeah. It does have a lot of nice functions like, normalize and stuff like that. So if you're gonna do what I did, I had to re-implement those things that are like not built into Zig, but it wasn't really that much things that I had to do. But then I think the end result is a lot nicer. I mean, it doesn't really matter that much now, but then also Zig has like built-in vectorization for the vectors as well. But it's not really, if you're just working with two-dimensional, like vector 2s, then it's not gonna matter that much. But it's just if you wanna say vector A plus vector B instead of vector A dot add vector B and stuff like that. It also sort of the order of operations becomes, you can read it in a different way as well. Okay, well, anyway. Yeah, so if you haven't seen it, I can show you here. So let's say we have a function here. Whatever, I need a function to actually have some code here. And so you have a vector A is a vector. So what I usually do is I define like a vector type like this. So I have this vector type now, and I can easily just say vector and then like, I don't know, 2, 3. So now it's a vector of 2 dimensions with 2, 3. And then we can say another vector here. And also if you know the type of the thing, you can also just say dot like this. So if you have a struct with a body, with a position or something, you can just say dot 5, 5, and that's the position there. And then you have result A plus B. So this will now be 7, 8. So you get this nice way of looking at the arithmetic. If you have, and then you can do all sorts of stuff. You can do this and whatever, And also, if you want to like divide by 2, what you have to do is you have to do like a splat 2. However, that's not enough because now you have to also specify what is the type. So you have to do like as vector like this. But essentially this will become a vector, this type here. with 2, 2. And what I've done is I wrote this little library which I call v, and then I have a function called scalar which returns a vector, and this takes x f32 and returns just, you know, xx. Or actually here you can't just say splat x because it knows the return type is a vector, so you can just return it like that. And then here now you can say scalar 2. So it becomes a little bit nicer like that. And then you can extend this to add like normalize functions that are not sort of built into SIG. You can add here. So I just think this is a nice upgrade for me, at least, from using the built-in sort of Rayleigh vectors. But really what pushed me into this was because I would notice that the built-in, I was doing some tests and I saw that like there was some sort of memory leak, and I'm not sure if this is correct or not, but I was thinking that, oh, it must be because of the Rayleigh vectors, because that's the only like function I was using, and I saw the memory usage go up and up and up. So I was saying, what's happening? There's like a memory leak in Rayleigh vectors when you just use add or something like that. So I don't know, but it doesn't make sense because it's just a struct with 2 floats. So, but yeah. I don't think that's the case. I think there was something wrong with what I was doing, but that was like initiating my adventure into building my own thing and then converting to Rayleigh whenever I needed to. Yeah, there's no malloc, but it's copied every method. Right. Well, if it's copied, yeah, if there's no malloc, then there should be no leak. So I don't know. There was maybe some function, because you didn't really see what was happening because Rayleigh was calling some other library or something. Or math, yeah. Or math. Sounds like a death metal person. Or math. Okay, anyway. So that's I mean, yeah, it's a little bit of work, initial work, but then once you have it, it's pretty nice to have. But then you also have like rectangle stuff. You can have like what I did was I implemented like converters between my version and Rayleigh's version. So and then just, you know, at the sort of points where you have to draw something with Rayleigh, then you convert. That's how I did it. Oh yeah, so this is like pause and game over. So I have some common stuff here, and then we have, if it's paused, then you can continue. Okay. I was thinking, like, is there anything I could say here? I mean, I'm seeing a lot of repetition. The only thing that's changing is the text and the Y. So maybe this could be somewhere where you put, like, you could have like a like a little localized struct here that you can use, where like 40 is like the line height or whatever, and then increase by that, I don't know, and then call like a function that has everything here. But you could have that. I mean, you have a rectangle. You could have a mutable rectangle that is changed, I guess. That's like almost all of the code here is like the rectangle. But that's just a super nitpick. This is really not, you know. I was just thinking about a way to sort of, because when I write code like this, I just feel itchy about repeating myself. Where did the numbers go? Okay, whatever. I know also that, you know, a lot of times you see code that you write yourself and you're thinking like, okay, I don't like this, but this will have to do for now. It's not important to fix this, optimize everything, you know, like premature optimization, or premature like refactoring. But it is interesting to look at this and think about, okay, how could this be how in Zig, how could you make this less repetitive? We're playing. Okay, so this is the play controls. We got the same button icon here. And the control texture. Okay. So, hang on. So we take a texture. Okay, so we're drawing I'm guessing we draw like a portion of the texture that is supposed to be representing the button. Oh, oops. Okay, now my time seems to be up today. But yeah, I mean, a really nice project here. I really like the structure of everything, and yeah, seems to be very solid. I mean, as I said, I'm not an expert SIG, so I can't give like full on maybe super good tips and stuff, but just, you know, the small things that I've seen, that I saw with that just is this, because like Zig related functional or features that might have been missed or yeah, not used. Yeah, the shape and the rectangles. Yeah, nice. Okay. Yeah, well, thank you for showing the project there. But yeah, I'll have to go now. So thank you very much for watching and joining me. And yeah, I'll see you later. Have a nice day.